Nice having you in class, great champions. In this class, I'll be teaching you the first topic for the term, indices. Indices is the plural of index. You will recall that an index shows the number of times a number or a variable have been multiplied by itself. So join me in this class as I teach you the laws of indices and how to apply them to solve mathematical problems. I'll see you. So indices is the power or exponent to which a number or a variable is raised. Indices also shows the number of times which a number has been multiplied by itself. So for instance, if you have a number 2 raised to power 6, which is equal to 64, the 2 is known as the base, while the 6 is known as the index. It can also be referred to as the power, or it can also be called the exponent of the number. Before you can solve any problem involving indices, you must know the laws or a set of rules that governs it. So these rules, there are about 7 of them. Over the next few minutes, I will be teaching you how to apply each of these rules. So let's take the first rule of indices, which is known as the multiplication rule. So to solve a problem using the multiplication rule of indices, let's take a look at the law itself. The law states that x raised to power a times x raised to power b is equal to x raised to power a plus b. Meaning that if you have a number that is raised to a certain power and the number is multiplying itself raised to another power, it's the same thing as putting down the base and adding the powers. And so the multiplication law is saying that x raised to power a times x raised to power b is equal to x raised to power a plus b. Let us take a look at an example applying the law of multiplication. So for instance, if you have 8 raised to power 3 times 8 raised to power 5, this is the same thing as 8 raised to power 3 plus 5, which is equal to 8 raised to power 8. You can decide to express 8 raised to power 8 in ordinary form. In that case, you will be multiplying 8 by itself 8 times. So that is the law of multiplication, which says that x raised to power a times x raised to power b is equal to x raised to power a plus b. The next law I'll be teaching you is the law of division. And the law of division is, suppose you have a number x raised to power a divided by x raised to power b. The law of division is saying that this is the same thing as x raised to power a minus b. So if you have a number raised to a certain power and is dividing itself raised to another power, it's the same thing as putting down the base and subtracting the powers. So I'm going to teach you an example using this law. X raised to power 9 divided by x raised to power 6 will be equal to x raised to power 9 minus 6. And of course, we know that 9 minus 6 is equal to 3. So you are going to be having the final answer as x raised to power 3. The next law we'll consider is the law of zero index, which is saying that x raised to power 0 is equal to 1. In a nutshell, what this law is saying that any number or variable raised to the power of 0 is equal to 1. Even if it is 1 million raised to power 0, it reduces to 1. It will be equal to 1. So let's apply this law. Suppose you are given 5 all over 16 raised to power 0. Applying this law of zero index, you are going to have 1 as the answer. So take note that anything raised to the power of 0 becomes equal to 1. The next law I'll be teaching you is the law of negative index. What is this law saying? The law is saying that x raised to power minus n is equal to 1 all over x raised to power n. So this implies that if you have a number that is raised to a negative power, and if you want to simplify that expression, removing that negative sign is the same thing as taking the reciprocal of the number. So for example, if you have 3 minus 2 being equal, this will now be equal to 1 all over 3 raised to power 2. You can see that the minus sign has disappeared. In the same way, if you have 2 all over 5 raised to power minus 6, you can swap the numerator with the denominator, leaving you with 5 all over 2 raised to power 6. So that is the law of negative index. When you swap, if it is a fraction, if you swap the numerator with the denominator, the negative sign disappears. The next law I'll be teaching you is the law of power index. And what is this law saying? The law is saying that x raised to power a bracket b is equal to x raised to power ab. That means if you remove the bracket sign, you will be multiplying the powers together. For instance, if you have the number 2 raised to power 2 bracket 3, it will be the same thing as 2 raised to power 2 times 3, which is equal to 2 raised to power 6. And we know that 2 raised to power 6 is equal to 64. Suppose you have two variables at the base of the number. If you open up the bracket, the power outside must touch the variables inside the bracket. So that means that x y raised to power a will become x raised to power a y raised to power a. So we have an example here where you have 3z raised to power 2. If you open up the bracket, you'll be having 3 squared z squared, which is equal to 9z squared. So just take note of this by the time we start taking more examples. So you have x raised to power a, x y raised to power a. So supposing you are now given a number that has a fractional base, and you have x all over y being raised to power a, you can break the when you can split the numerator from the denominator. In that case, you will now be having the numerator carrying the power and the denominator also carrying the power. So if you have 2 over 3 raised to power 3, it's the same thing as 2 raised to power 3 all over 3 raised to power 3, which is equal to 8 all over 27, because 2 raised to power 3 is 8 and 3 raised to power 3 is 27. And so you can separate the numerator and the denominator, and each of them will carry the power. So let's take some examples to illustrate some of the laws that we've taken so far. So the first question we are taking is to simplify the expression 2a raised to power minus 1 times 3a bracket raised to power 2. We are asked to simplify this expression. And so how do we go about simplifying this expression? We are going to I'll be teaching you how to use the law of indices that we've done so far to simplify this expression. And so 2a raised to power minus 1 times 3a raised to power minus 2. The a raised to power minus 1, when we take the reciprocal, it will become the denominator. So you have 2 all over a. Multiplying 3a squared will be the same thing as 3 squared a squared, which is equal to, we know that 3 squared is equal to 9. So you have 2 all over a times 9a raised to power 2. And when you multiply the two expressions together, you'll be having 18a squared all over a. So when the a at the denominator, will strike out one of the a at the numerator, leaving you with 18a as the final answer. The next question we'll be taking involves the law of division, whereby you are told to simplify the expression 75a squared b raised to power minus 2 all over 5a cube b raised to power minus 3. And so we are asked to simplify this expression using the laws of indices. To simplify this expression, we are going to break the division sign across each of the variables. So the expression will become 75 over 5 multiplying a raised to power 2 divided by a raised to power 3 and b raised to power minus 2 dividing b raised to power minus 3. If you apply the law of division to simplify this expression, you will be having 75 divided by 5, which is equal to 15, and then a raised to power 2 minus 3. Remember the law of division. And so you will have b raised to power minus 2 minus 3, which will now become 15a raised to power minus 1, b raised to power minus 2 plus 3. And if you simplify this equation further, you are going to be having 15b all over a as the final answer for this particular question. And so let's take another question, still applying the laws of indices. You are told to simplify the expression 16 all over 9 raised to power minus 3 over 2. And so you can see that this number is an example of the law of negative index or fractional index. So we are going to, this one now will become, by the time we know that 16 over 9 is a perfect square, which is equal to 4 all over 3, because the square of 16 is 4 and the square root of 9 is 3. So you have 4 over 3 raised to power 2 multiplying minus 3 all over 2. So when you multiply the powers, it will leave you with 4 all over 3 raised to power minus 3. To remove the negative sign in the power there, you swap the numerator with the denominator, leaving you with 3 all over 4 raised to power minus 3. And when you evaluate this further, you have 27 over 64. So the last law we'll be taking is the law of fractional index, which is saying that x raised to power a all over b is equal to root b x raised to power a, meaning that you take the denominator of the fractional power to the left side of the root sign while you raise the base to the power of the numerator. This is known as the law of fractional index. It helps us to simplify expressions that have a root sign and this is raised to a fractional index. So I will teach you an example involving this law. So if you have 16 raised to power 3 all over 4, it will be the same thing as the fourth root of 16 raised to the power of 3. We know that the fourth root of 16 is 2, so you'll be having 2 raised to power 3, and 2 raised to power 3 will be 2 multiplying itself 3 times, which is equal to 8. And so we are going to take further examples involving this law of fractional index. So let's take this example. Simplify the expression the cube root of 8a raised to power minus 3. And so to simplify this expression, I will be applying the law of fractional index. And so we know that the cube root of 8a raised to power minus 6 is the same thing as 8a raised to power minus 6 bracket 1 all over 3. And we know that 8 is the same thing as 2 raised to power 3. So you'll be having 2 raised to power 3, a raised to power minus 6, bracket 1 all over 3. When you open up the bracket, the 1 over 3 outside will affect both 2 raised to power 3 and a raised to power minus 6. So you'll be having 2 raised to power 3 times 1 all over 3. Another bracket, a raised to power minus 6 times 1 all over 3. 3 will cancel 3. So leaving you with 2. Why a raised to power minus 6 times 1 over 3? 3 will cancel 6, leaving you with minus 2. And so the expression will become 2a raised to power minus 2. By the time you take the reciprocal of a raised to power minus 2, you will be having 2 all over a raised to power minus 2. So that is the final answer.
I hope you had a nice time watching this video. If you have any comments or suggestion, please drop it in the questions and notes section of this page. Also remember to attempt your quizzes and assignments as they will form part of your assessment this term. I'll see you next time. Bye bye.